This is a demonstration of the Earth, Sun, Moon system to demonstrate the phases of the moon and how that corresponds to rise and set times. This is a activity of figure 2.21 in your book, and you can read along the description for how to do this in the Understanding Phases section of chapter 2.3. So in my setup, I've got my moon stuffy. I know you probably don't have one of these, but any ball or sphere will do. You're holding it at arm's length. The camera here is the Earth. This is where your head is. And then I've got my sun right there. Now, since this isn't a focused light, you won't see the quarters and gibbouses quite so clearly, but it's good enough. So when we start off, we line up the Earth, the moon, and the sun right like this. And this would be a new moon because the sun is maximally illuminating the back side of the moon here. And so we are seeing the dark side. And if it were a solar eclipse, we would be lined up, the moon's tilt and the Earth's orbit's tilt would be lined up like that. But that doesn't usually happen. So if we're in the northern hemisphere, we begin to then rotate counterclockwise, which looks to the left to me. So now we start to see the crescent on the right side, a quarter, a gibbous, and a full moon. You'll notice that I have to move this out of the way because my head's in the way. If your head is in the way, that's the Earth blocking the sunlight from the moon, so the moon's in the Earth's shadow. That would be a lunar eclipse. However, typically we have a full moon here. And then as we continue to rotate the way the Earth and moon work, we then see the waning side, the quarter, the crescent, and this. So that was for how the phases work in terms of the relationship between the sun, moon, and the Earth. Now, to represent the rise and set times of that, we're going to be turning the camera, or the Earth, in reference to where the moon and the sun are. So let's try to follow along. So let's think about the rise and set times for a first quarter moon here. So midday is when the sun is directly overhead. So this is when you would be looking like straight up at the sun, right up high in the sky. At this time, due to the configuration of the sun, earth, moon, the quarter moon is like hanging out right on the edge of your periphery, so it is right about to rise. So the quarter moon rises at noon. Then, as the day's going along and the sun's moving across in the sky, then as the sun is on the edge of your horizon, so the sun is setting, this is when the first quarter moon is highest in the sky. And then as we keep going, and I try to keep my arm there but keep turning, once we're 90 degrees around that way and the quarter moon is setting, then this is when we are opposite from the sun, so it's the middle of the night. Now let's try to think about this for a full moon. So the full moon is when there's kind of a lineup of the moon and then the Earth and then the sun. So if we start at noon, when the sun is directly overhead, we can't see the moon at all. And then as the Earth is rotating, then as the sun is setting, so it's at the edge of our vision, 90 degrees off to the right, then at this time, the full moon is just becoming visible on the left side, so the full moon is rising at sunset. Then the Earth continues to rotate, and then the full moon is up. So when the full moon is highest in the sky, it is midnight, because the sun is on the other side of the Earth. And then, as the night continues, at that point, the full moon is setting at sunrise when the sun is beginning to peek up over on the left now.